Welcome. In this video, we are going to go over how to integrate this rational function using the method of partial fraction decomposition. Here we are in the case where this factor, this quadratic factor, is irreducible, and we have two copies. So we are in the repeated irreducible quadratic factors case. And for a case like this, I'm going to strongly urge that you use technology for the actual partial fraction decomposition. Now, as you can see here, I've used Wolfram Alpha to find the partial fraction decomposition of this rational function. Let's go ahead and use this information to integrate. So here in front of you, we have the partial fraction decomposition of this rational function as computed using technology. And now we're going to use this to integrate. So I'm going to split this into three integrals, and not the three you think. This will be the first one, however. So the integral of 1 over x dx. Plus, and then the integral, and I want all the values that have an x in the numerator. So I need x divided by x squared plus 1 squared, and I need negative x divided by x squared plus 1. Finally, I just need to subtract the integral of 1 over x squared plus 1 dx. Well, this first integral is just the natural log of x. And for this middle part, let's do that on some separate paper. I'm going to tackle this using a substitution. So if you notice, I have an x and an x in common here. So this is x times 1 over x squared plus 1 quantity squared minus 1 over x squared plus 1 dx. So let w equal x squared plus 1. Then dw is 2x dx, or 1/2 dw equals x dx. And I have an x dx right here, which will be replaced with a 1/2 dw. So I have 1 over w squared minus 1 over w times 1/2 dw. This is just 1/2 times the integral of 1 over w squared minus 1 over w dw, which evaluates to 1/2 times negative 1 over w minus the natural log of w plus a constant, say c1. And then before I back substitute, let me fix my notation here. I actually need parentheses since this 1/2 applies to both of these integrals. So now back substituting, that is replacing each w I see with an x squared plus 1, I get negative 1 over 2 x squared plus 1 minus the natural log of x squared plus 1 divided by 2 plus c1. And the last thing I'm going to do is replace these absolute values with a parentheses. This quantity, that is this expression x squared plus 1, will always be greater than 0. It's this parabola here. So there's no need to have an absolute value there. Now let's go back and just insert this portion into the integral we're actually interested in evaluating. Okay, and this final integral, I put out a video on it. If you've been following along either my YouTube channel or my Canvas course page, you'll see a link coming up in the top corner of your screen in this section showing you how to integrate this. Of course, if you already know what this is, you don't have to watch that video, but if you don't understand the next step, I suggest you go back and watch that video. So this is negative tangent inverse of x plus c. So this rather daunting looking integral of a rational function integrates to this expression here. I hope this video has been helpful.